So in journal physics, another topic we have is about pressure. So if we talk about the topic of pressure, we will discuss about the pressure in solids, pressure in liquid, and pressure in gases. So there are three different states. So we will discuss pressure in three different states also. So the first one is pressure in solids. So the definition of pressure in solids can be defined as it is the force acting per unit area. So the basic definition of the pressure is force acting per unit area, and this can also be defined as the pressure exerted by the solids. So when we are talking about the solid objects, so force acted per unit area or force acting per unit area can be defined as the pressure of the solids. And the formula for pressure P is equals to F upon A. This is the formula for pressure. And the SI unit of pressure, according to the formula, the SI unit for pressure will be Newton per meter square. But we use a different unit which is equals to pascals, PA. Because pascals is the name of the scientist and we have a law related to the Pascal's name. So that's why we use the name of Pascal as the SI unit of the pressure. So this is the basic definition of the pressure and the concept of pressure in solid. And according to this definition, if we apply this formula, so this is very easy, very simple formula for pressure in solids. So let's suppose if you want to apply this formula, so we can apply this formula on the topic of pressure. So this is the chapter of pressure.
Yeah,
Yes.
could you show the notes?
The formula of pressure is P is equals to F upon A and the SI unit is pascals. We use pascals as a unit, not Newton per meter square, but you can also write Newton per meter square. That is also right. But mostly you will get the SI unit in pascals. And if we consider questions related to the pressure in solid, this is the formula related to the solid bodies. We apply this formula in solid objects. So for example, if we consider question, in question it is mentioned a block of weight 900 Newton has a rectangular faces. So the weight of the block has been given. And according to the formula, we have force. So weight is also a type of force. So basically force is given. The diagram shows the lengths of the sides. The block can rest on any of its faces. What is the minimum pressure that the block can exert on the ground when resting on one of its faces. So now they are talking about minimum pressure. So minimum pressure means, according to this formula, we can say that pressure is directly proportional to the force. So according to the formula, if the value of force increases, so pressure also increases. Pressure is directly proportional to the force. Second, pressure is inversely proportional to the area. So it means that if we increase the area, so the value of pressure decreases. So this is the relation between the quantities. So if we increase area, so pressure decreases. And if we increase the force, pressure also increases. So this is the concept of direct and inversely proportional to the quantities with respect to the pressure. And in the question is minimum pressure. Minimum pressure means we have to select the smallest value. So smallest value of the pressure means that weight of the body remains same, or we can say the force remains the same because the only one force or the one value of the force is given in the question. After that, we have to find out minimum pressure. Minimum pressure means pressure is directly proportional to the force. Force is constant, so it means it remains same. But pressure is inversely proportional to the area. So if we increase the area or if we select maximum value of area, so we got minimum value of pressure. And it's up to you which side you select to find out the area. One option is that we will select these two values, or the other option is that we have to select the other two values. So this is one possibility. And if you tilt this block, because it is mentioned, the block can rest on any of its faces. So this is area 2. Area 2 means block can be like rest in this state. So this is another possibility for the block. So we know that to find out the maximum area, we have to select A1, because when we choose A1 means 0.5, 0.4. It gives you answer. And for example, if we select A2, So this is the concept of A2. So it means we have to choose the value of A1 because the value of A1 is greater as compared to A2. So pressure is equals to the value of the force is 900 divided by area. Final answer is equals to 4500.
So could you explain the part where you have written P is directly proportional to F and P is inversely proportional to 1 over A?
Basically, in this question, they are asking about the minimum pressure. They are talking about the minimum pressure value. So minimum pressure means we have to consider the quantities given in the question, that what is changing, what is constant. So according to the question, we observe that to find out the minimum pressure, either we have to decrease the force, because if we decrease the force, let's suppose, so pressure decreases, but force is same. Force is not changing. So it means this option is not possible right now in this question, right? So we are not able to change uh, the force quantity. So the second option that we can apply on this question is for area. So if we change area, so, or if we choose different values of area, so final value of the pressure will be different. So that's why we mention these two factors. It is not compulsory to write down these factors all the time, but right now this is the first question, so that's why we mention these factors. So if we increase the force, pressure will increase. If we decrease the force, pressure will decrease. In the same way, if we increase the value of area, so the value of pressure decreases because both are inversely proportional. And this is the key point of the question basically, because we required minimum value of pressure, minimum value. So to find out minimum value of pressure, we have to select maximum value of area, right? Because when area increases, pressure decreases. So that's why we consider the greater area value. Okay.
Okay.
Okay. Next we have,
And so if you were to have a square instead of a cuboid, like a cube instead of a cuboid,
basically it depends upon the shape also, but they will not ask very irregular or that type of shape. So that's why,
so uh,
yes, so that's why we will consider the simple shape.
okay, last question, how do we get to know that we're supposed to use inversely proportional idea here?
Because in this question, they are talking about minimum pressure. So for minimum pressure, there are two options. Either you have to decrease the force, option number one, but force is constant given in the question. So force is not changing. Second option is to decrease the area or increase the area. So if we increase the area, so the value of pressure decreases because both are inversely proportional. And if we decrease area, so pressure increases. So minimum pressure can be find out with the help of greater value of area. Because when we use the greater value of area, so then you will get the smallest value of pressure in your answer, right?
Okay, so got it. It's clear now. Thanks.
Okay. Okay, so This is one question related to the solid, and from solid we have very few questions because this topic is very easy to mark. For example, this is another question. A brick of weight 80 newtons stands upright on the ground as shown. What is the pressure it exerts on the ground? So try to find out the pressure from this diagram. So in this question, you have to apply the same formula again. Pressure is equals to force upon area. The value of the force is 80 Newton and the value of area. So area, this is the surface that is in the contact with the ground. 5 into 10, 50. So we have to select that part which is in contact with the ground to find out the area. So 5 and 10, these two sides are in contact with the ground. So 5 into 10, 50. So 50 is the area and 80 Newton is the value of the weight.
Sir, the correct option would be D, right?
Yes, sir. B, 1.6 Newton centimeter cube
Okay.
square. And sir, I want to ask that and what places we're going to use the Newton over centimeter square, and where would we use PA?
Basically, in most of the question, we got PA pascals. But if value is given in Newton per meter square, or if you write in your answer Newton per meter square, so that is also fine, right?
Okay, sir. So if I write P instead of n Newton over centimeter squared, it would
That is
also
also
be
fine.
acceptable.
Yes.
Okay, sir. Okay.
Okay, so this is the question related to the pressure in solid. Next, next idea is about pressure in liquid. Because in liquid we have not any particular shape, particular like volume for the liquid. So that's why the formula for pressure in liquid is different. So pressure in liquid can be calculated with the help of a formula. It can also be defined as the pressure of the water particles exerted on the body. So the formula for pressure in liquid can be defined as P is equals to rho GH. This symbol represents density. This symbol represents gravitational field strength, and H represents the depth. So, for example, if we consider a container, so in this container, if it is filled with water to a certain surface, and for example, if this is the object placed in this container, so the depth of this object from the surface of the water can be represented with the value of h, and definitely there must be some density of water or whatever the liquid, and the value of g is always the same, 9.81 or 9.8 meter per second square. So with the help of these quantities, we can find out pressure in liquid. Okay. And if we consider questions from pressure in liquid, so there are so many questions related to pressure in liquid because it depends upon the diagram also, and it has also a formula to calculate. And from this formula, you can see that all quantities are directly proportional. So for example, in this formula, the first factor is increasing density increases the pressure because it is directly proportional to density. So if we increase the density, so pressure also increases. Second factor, increasing the value of gravitational strength also increases the pressure. And the third factor is increasing the depth value of pressure also increases. So these are three quantities, and these three quantities are directly proportional to each other. So if we increase any one quantity, so pressure will increase, or if we decrease any one quantity, so the pressure will decrease also. So this is the concept of pressure in liquid. And for example, if we apply this formula on the questions, so let's see how to use this formula on the questions. This is the first question. 4 beakers contains the same liquid. At which point is the pressure the greatest? So at which point you think, or in which diagram you think that the pressure in liquid is greater?
For D.
A.
Option A, option D, okay. So basically in this
Sir,
question,
is it
It is D.
okay.
Is it
So
A?
they're asking the pressure according to the points that are marked, right? Like on the part A, they're showing the pressure on the surface that there wouldn't be much pressure, and then at B, pretty shallow. C goes deep and D goes to the end.
Okay. Basically, if we consider pressure in liquid, so the formula of pressure in liquid is rho GH. So basically, we have same liquid. Same liquid means same density, and definitely the value of G is also same. And the other option is the depth. So basically, depth is different in all the options. So in this idea, if we apply the concept of the depth, so in option A, we can see that this point is already on the surface. So there is no depth. If we consider the swimming pool, so when we are deep in the swimming pool, so definitely the depth of from the surface of the liquid is greater. In option A, it is on the top, it is on the surface. In option B, it covers some depth from the surface. In option C, it also covers some depth from the surface. In option D, it also covers some depth from the surface. So it means option C is the right option because the depth is greater. So it will create the greater pressure in this container. Okay. So this is the idea.
Okay.
And next we have question number 5. Question number 5 is the diagram shows liquids in containers. Which column of liquid exerts the greatest pressure on the base of its container? So greatest pressure on the base of its container. So this time we have values given in the question. So from the values you have to select which option gives you the greatest pressure on the base.
So C.
Option C, okay. Again, we have to use the same formula: density, gravity, and the value of depth. So basically we have densities given. So the density of water is greater than the density of paraffin. So it means paraffin is not possible because density is less. So paraffin always gives you small answer because the value of paraffin, density of the paraffin is less. Value of G remains the same. Now the value of depth. So the value of depth is
Uh, Sir,
again,
I think B is gonna be the right answer.
yes, the depth of B is greater than all of the other options. So B is the right answer. Because if we apply formula, so the pressure we got over here, we can calculate like 0.8 into 9.8 into the depth, right? So in the same way, we have option B, C, and D. So in option B, we have greatest value of density, greatest depth also. So option B gives you the greatest pressure exerted on the base of the container, right? So that is the simple answer. Okay, next question. Okay, this topic is excluded from a new syllabus. This is the topic of manometer. So manometer is not in our new syllabus. This topic, manometer. So manometer is now excluded from new syllabus. Question number 10. The base of a rectangular storage tank is 2 by 3 and the tank is filled with paraffin to a depth of 3 meter. The density of paraffin is 800 kg per meter cube and the gravitational field strength is 10. What is the pressure at the bottom of the tank due to paraffin? Now in new papers we know that the value of G is 9.8. So now again calculate the pressure at the bottom of the tank due to the paraffin. So we have to apply the same formula rho g h to find out the the pressure in the liquid again. So formula is the value of density is 800 and the height is 3 meter. According to the diagram, this is the depth or this is the height.
Multiplying this is giving the answer 23,520. So if you were to round it off, it would be
24,000.
C. Yes,
Correct.
sir.
Okay. So you can see we have very easy questions related to the pressure in liquid also. And they are asking that question again and again. Again, we got manometer part. This is excluded. Okay, after the pressure in liquid, we have another idea related to the pressure, which is called atmospheric pressure. Basically, atmospheric pressure is the pressure exerted by the air particles which are present in our surrounding on the body. Basically, when we are in a rest state or when we are sitting, when we are standing, so we are not able to feel that atmospheric pressure or the pressure exerted by the air particles in our surrounding. But for example, when we start running, so when we start running and during that process we observe we are not able to breathe smoothly, right? Because we are getting external pressure from the atmosphere. And when we are getting external pressure from atmosphere, so because of that, it becomes difficult to breathe. So that's why atmospheric pressure is very much high in our surrounding, but when we are inhaling or during the process of inhale and exhale, we are not able to observe that pressure clearly. But the pressure of atmosphere or the pressure of air in our surrounding is very much high. Okay.
Okay, sir. So, sir, the only pressure that we'll feel of the atmosphere is when the wind blows hard.
Yes. So when the wind is high or when we are running, so in that case, we are able to feel that atmospheric pressure. Otherwise, it is difficult to observe that. Okay.
Okay, sir.
Sir, can you switch back to question number 10? I didn't complete noting it down.
This one.
Yes, sir. Okay, sir, I'm noting it down.
Okay. So basically, the idea of atmospheric pressure is very simple. Atmospheric pressure atmospheric pressure means air particles are in random motion state and they are moving with high speeds. And definitely when they are moving with very high speeds, so they also collide with the other bodies and with the other surface in the surrounding. So when they collide, other body and surface, it exerts force on certain area. For example, if we consider square box, so definitely that square box has certain area. So when air particles exert force on it, so force per unit area creates the pressure, which is called atmospheric pressure, because it is exerted by the particles in the atmosphere. Right? This is the concept of atmospheric pressure, very easy. In simple words, it is the pressure exerted by the air particles in the surrounding we have. And further, if we consider the formula, so there is no formula to remember related to the atmospheric pressure in this chapter. So we only need to know about the idea of it. There is no formula, there is no calculation related to the atmospheric pressure calculation, but the value of atmospheric pressure is constant. So the value of atmospheric pressure remains the same. It will not change. So we got the same value every time. So we don't need to use or calculate any other value related to the atmospheric pressure because that remains the same. So the constant value of atmospheric pressure can be written as atmospheric pressure 10 to the power 5 pascals. And normally, if we consider any condition, for example, if we consider the condition of the same water surface, and in the water surface, if object is at a certain depth, let's suppose at this depth. So in this condition, there are two values of pressure acting on this object. The first one is the pressure of liquid, and the second pressure or the second value of the pressure is the pressure exerted by the atmosphere. Because it is open to the atmosphere, so definitely atmosphere also exerts pressure on the liquid.
The P liquid means the pressure in liquid.
Yes, basically P liquid means the pressure exerted by the liquid, and PATM short form atmospheric pressure. So that is the pressure exerted by the atmosphere on the liquid, because atmosphere exert pressure on the liquid, then the pressure exerted by the atmosphere adds up with the pressure exerted by the liquid, and they both combine acts on the body. under the liquid surface, right? So if they talk about the total pressure, so total pressure will be equals to pressure in liquid plus atmospheric pressure, right? So these two values of the pressure we have to add to find out the total value. Okay.
Okay, sir.
And you will get questions also from this type of situation when we have two values of pressures combined together. So for example, okay, if we consider theory questions also, because some questions are related to now Boyle's law. We will discuss that Boyle's law also, but right now the important is to practice the atmospheric pressure concept and pressure in liquid plus pressure in solids. Okay, so let's find out questions related to the pressure. Okay, this is the question. Figure 4.1 shows a long vertical tube sealed at the base and open at the other end. The tube is 1 meter long. The cross-sectional area of the tube is equals to this value. It is filled with liquid of density. So this is the density of the liquid given. Now the atmospheric pressure is also given. Calculate the total pressure in the liquid at the bottom of the tube. So in this diagram, you can see that it is open on the top. It is open over here, but it is closed at the bottom. Now they are talking about the total pressure in the liquid at the bottom of the tube. So they are talking about the same thing that we discussed, total pressure. Total pressure means we have some depth of the liquid given. So for total pressure, pressure in liquid plus atmospheric pressure. So the pressure in liquid can be calculated with the help of the value of density is 1.4 10 to the power 4. Value of G is constant 9.8 and the height of the tube is 1. It is mentioned in the question. The height of the tube is 1 plus the value of atmospheric pressure. So we have to solve this equation. 1.4 exponent 4 multiplied by 9.8 multiplied by 1 plus 1 exponent 5. Total pressure, or you can also round it off to 2.4 10 to the power 5. So this is the value of the total pressure we calculated from this question. Second part is calculate the force exerted on the inside surface of the bottom of the tube. So inside surface and the value of the force. So for the value of the force, we have to use this cross-sectional area. So inside of the tube means we have to use the value of pressure. So the value of pressure we calculated is already given 2.4 10 to the power 5. This time they are talking about the force. So force is equals to pressure into time according to the formula. Cross-sectional area is 4 into 10 to the power minus 4. After multiplication, 94.88. So round off 95 Newton is the final answer. Okay. So this is another question from the pressure topic. Okay. Now we have another part of this question. Basically, this part of the question is related to the barometer concept. This diagram represents the setup of barometer. Basically, barometer is like a device, we can say, which helps to measure atmospheric pressure. And how we can measure atmospheric pressure with the help of the barometer, that is very simple. In this diagram, in this statement, you can see it is mentioned a small sheet of glass is placed over the open end of the tube. So when we place glass sheet over that, so it means now we have only liquid in the tube. There is no air particles because it is closed from the both ends. So when the tube is closed from the both ends, so no air particles are present there, only the liquid particles are there. And now uh, the tube is inverted in a container of the dense liquid. So initially we have liquid in the tube, and when we place that tube in inverted form into the same type of liquid tube, into the same type of liquid container, so that will give you a different result. The open end of the tube and the sheet of the glass are a short distance below the surface of the liquid. So in the diagram, you can see they are not in contact with the base of the container. They are at a short distance from the container. And the question is, the glass sheet or the sheet of the glass seals the open end of the inverted tube. So when we remove the sheet of the glass, so describe what happens in the inverted tube when the sheet of the glass is removed. So answer is very simple. And the working of the barometer is when a tube filled with liquid mercury was turned over in a dish that dish or that container is also filled with mercury and the mercury level. So basically now this is the answer of the question. When we remove that sheet of the glass, so the mercury level in the tube falls until it becomes constant. So the level of liquid starts to decrease in the tube and it stops until it becomes constant. And why it stops basically? So for example, the level of the water decreases to this part and this region becomes a vacuum, right? Because when water or liquid moves in downward direction, so definitely the upper side of the tube becomes empty. And the question is why it stops. So answer is the level stopped because the atmospheric pressure. This container is open, so atmospheric pressure is acting from the outside. So that's why the atmospheric pressure from the outside it match with liquid pressure inside the tube, right? So this is the concept of the barometer, and this is the working of the barometer that we can apply on every concept of the barometer. So in this question, the first part they are talking about, describe what happens in the inverted tube when the sheet of glass removed. So we already mentioned the answer over here. When we remove the sheet of the glass, so the mercury level in the tube falls until it becomes constant, and this level is stopped because the atmospheric pressure from the outside becomes equal to the liquid pressure inside the tube. So when both pressures are equals to each other, so the level of the liquid starts to it stops to fall in downward direction because both values are now constant inside and outside. Then
So by removing the glass sheet, it means to uncap the tube. That means it would unleash all the mercury in the glass.
yes, when we remove this sheet of the glass, so this mercury in the tube and the mercury in the container, they are now in contact with each other, right?
Yes.
So they are now in contact with each other. So that's why the level of the liquid or the level of the mercury in the tube starts to decrease. Okay. And it decreases until it becomes equal to the pressure value outside, or it becomes equal to the atmospheric pressure outside. Okay.
Okay, sir.
So this is the concept that we have to apply in the atmospheric pressure idea. Okay. So these are the concepts related to the pressure in solid, pressure in liquid, and atmospheric pressure. And after this, you can also practice the other questions from this worksheet related to the pressure. And we will discuss the rest of the topics of the pressure, like Boyle's law, the calculation of the Boyle's law, the formula we use in the next class. And we will practice the other questions from the pressure in next class also, right?